It's your old pal Lucid Stew again. I have extended my grid-based puppet movement to include a check for missing tiles, ability to handle changes in elevation, and I've added an isometric camera. I've had some requests to cover this whole concept step by step, so I'm going to do that from the beginning. If you saw my last video on the subject and everything was clear, skip to 11 minutes 11 seconds for the new stuff. During the intro I created a cubic sculpt. The size can be varied, but we'll talk about that later. I'm then taking a tag and surface snapping that to the sculpt in order to associate the tag's logic with the sculpture. I'm going to rename the tag so I can have other gadgets look for it. Back to the tag and sculpt for a moment. It is not necessary to snap that tag to the sculpt at this juncture, but it could be useful in the future if we want to move pieces of the grid around during play, which we'll work on eventually. I'm going to make a grid by taking the cube and cloning it. Your grid can be any size the engine will support. For experiments I've done, this should mean a 125 by 125 grid is possible, and that would be quite large for the types of games that utilize this mechanic. For the purposes of this demonstration, I'm creating a 9 by 9 grid. I'm going to grab a basic blank puppet. I get it from the Dreamiverse, but it's also available in a gadgets menu. I'm scaling the puppet down to better match the grid. We'll run into some problems with this later. I haven't figured out exact ratios. Let's just say the size of the puppet and a bunch of other factors combine to overshoot the grid or not. How that occurs is something you'll have to figure out as you resize your grid or your character. I'm scoping into the character so I can open the character's microchip and access its logic. Once I've done that, I can scope back out and work on the logic in the scope of the scene. I'm going to remove some unnecessary components. I removed the health manager and the jump keyframe since I have no need for them. You can also delete the auto guide and the sound effects as well, but they're not wired up to anything, so I leave them in and set them aside. I do not need any of the current wiring, so I'm going to delete it and start fresh. What I want to do is wire this up so I can control the puppet with only the D-pad. I want this because the directions on the D-pad are definitive, and there is no mixing of axial information like with a thumbstick. We're going to accomplish this with a selector. We're going to use the selector as a state machine with 5 states, 1 state for each direction of the D-pad and 1 state for no button pressed. We're going to wire up the individual D-pad outputs of the controller sensor to selector inputs B through D, leave A blank to represent a state where nothing is happening. That's why it has no input. You want to be careful not to use the D-pad output on the second tab of the controller sensor, as this outputs different information than what we'll be using here. We're going to hook up the D-pad outs to the selector inputs, 1 for each, and each one representing the state of that directional movement occurring. We're going to lay down a through node and hook up the selector output for each state to the input of the node, except for A, which represents no buttons pressed. This node will combine all of these signals into a single output, which will act as a state indicating that the character is moving in some direction. I'll get into why we want that in just a bit. Another thing we want to do is hook up the D-pad information going through the selector to the walk input of the puppet interface. This will cause the puppet to walk when a D-pad button is pressed. However, we can't hook these two up directly because the D-pad signal is not the same type as the walk input. A D-pad directional outputs 1 when it is depressed and 0 when it is not. The walk input is looking for thumbstick information. Thumbstick information is made of 2 numbers representing the 2 axes of movement. Those 2 numbers vary from 1 to -1 depending on what direction the thumbstick is being pressed and how far. In order to get this to work, we have to adapt the D-pad signals and make them look like thumbstick signals. We're going to put all that work into a microchip to keep things organized. This is fairly simple if you know what the thumbstick is supposed to output. When a stick is pressed directly up all the way, it outputs a 1 in the y-axis and a 0 in the x-axis. Down is -1 in the y-axis. Right and left work the same way, but with 0 in the y-axis and 1 and -1 in the x-axis. Our D-pad signals are either 1 or 0, so we assign them their proper axis and then combine them with another number to get a stick signal that contains 2 numbers. We do this with combiners. Remember, sticker information runs from 1 to -1, so we also need to multiply our D-pad press signal of 1 by -1 to represent a stick which has been pushed all the way down or to the right. We take the selector output B, which is the up D-pad state, and run it into the negative input of a combiner. Then the C output, which is D-pad down, into a calculator to turn it negative. We do this by wiring the signal to calculator input A, changing the calculator to multiply, and then setting B in the calculator to -1. This will cause the output of the calculator to be the negative of the A input. Then we connect the result output of the calculator to the negative input of the second combiner. Hook up C and D from the selector the same way, except to the positive input of their combiners. Now I want to hook up all 4 of those signals to the walk input of the puppet. The state machine of the selector ensures that only one of these signals will be active at any given time, so it's okay to hook them all up together. Next, we're going to open up the controller sensor so we can disable the control input while the character is moving. That way the character can traverse grid spaces without being interrupted by the player. We do this by connecting the disable controls input to the output of the node that represents the while moving state. For this setup, we use a couple of trigger zones to determine when the puppet should go and when it should stop. The first one handles when the puppet should continue moving. This one is placed in front of the character just past the tag that the character is currently on. I'm using cylinders for the zones. You can use any shape that works for you. We want the zone to be small enough so that it doesn't touch the current tag and also allows for a little play for instances when the character is turning. We'll need to adjust the Z-axis size later. For now, it doesn't really matter. You then want to move the zone as close as possible to the current tag to improve the chances that the zone will see the tag in front of it after a turn. The objective here is to set up a state where the trigger zone in front is activated at the same time that the character is moving. That will indicate that the character is approaching a tag and should prepare to stop. In order for that to happen, we have to set the trigger zone to detect grid marker tags. We are then going to use a second trigger zone to determine when the character has arrived at the new tag and that it should stop moving. We're going to place this zone dead center on the current tag. When the zone detects the tag, it causes the movement state to cease and the character will stop. Because of this, the tag must not be active while the character is standing on it. Otherwise, this zone would never allow you to move. It's a bit of a paradox, but will work if we do it in the right sequence. We're going to solve this by using our front trigger zone and the while moving state. We can set up an AND statement to only activate the second trigger zone when the puppet is moving and the front zone is activated. This does 2 things. First, it means power to the second @tag zone is off when the character isn't moving. This way, the zone is off while waiting for input from the player and allows us to move off the current tag. Secondly, we can determine when the character is moving but not on a tag. This is true when the front trigger zone is activated and the character is moving. We can use those facts to safely turn the second @tag trigger on so that it can detect the tag it is approaching. Currently, the signal is continuous, but we want to switch the power of the @tag trigger zone off and on. We'll do that with a signal manipulator. The output of the AND gate is connected to the input of the signal manipulator. We then open it up and change it to a custom remapper type. We want this to send a toggle signal when it receives a signal from the AND gate. This represents the moment the in-front trigger detects the tag in front of the character. We then connect the output of the signal manipulator to the power of the @tag trigger zone. This way, the power for that trigger zone turns on or off each time that AND statement becomes true. That's set up, now we have to figure out what the @tag trigger zone does when it's activated. We'll send a signal to the signal manipulator and also the A input of the selector. The signal to the signal manipulator will turn the @tag trigger zone off. The signal to the selector activates the A state, which we've set aside to represent the state of not moving and waiting for input. When the A state is activated, all the others are deactivated and signal ceases to flow to the puppet interface. In this way, we return the puppet back to the state it was at while initially standing on the tag. This gets us nearly to the point where my first video on this subject ended. All that's left is making sure that the trigger zones are looking for the correct tags. I'll also go into the puppet menu and change the turn speed so that turning interferes with our setup as little as possible. So let's test it out and make sure everything works. Nope. Looks like we have some troubleshooting to do. I'll spare you the details of the 5 minutes it took me to figure out what was wrong, but one issue was that my combiners for the D-pad signal conversion weren't set up correctly. Here we're outputting a signal type, and what we want is a stick type. This is why the character went running off diagonally, so let's change all of those. And we'll try it again. Now we're up and running. We've made it to the end of my first video, so let's extend the concept. I'm going to set up a grid checker that will see if we can move into a space before player input. If the answer is no, player movement in that direction will be blocked. This way we can place obstacles in the tag grid and can keep the player from wandering off the edges. The first step is to create an interrupt between the controller sensor and the selector. This way we can cut the signal and keep the character from entering forbidden states. Let's get rid of those signals for now while we work on the new logic. I need an object that will check the tags in each movement direction at the character's position that will not turn with it, so I'll sculpt another cube. We have to do this because we've set up the signals coming from the D-pad as absolute, regardless of character orientation. This is a design choice. I'm doing this to pair the character with an isometric camera and also to keep movement independent of the camera so that I can rotate view around the character while maintaining the integrity of the input. But that's a subject for a future video. I want to place the new cube at the same position of the character, and I'll eventually add some logic to make it maintain the same position as the character. I'm going to organize the logic for the new sculpt in a microchip, which I will surface snap to the front of it. We're in the new microchip and I want to place 4 trigger zones, one for each cardinal direction. These will check to see if I can move in each direction that the D-pad allows. The shape on these zones doesn't really matter as long as they contain only the tag of the cell they're supposed to check. I'm using cubes to demonstrate clearly that they are checking grid cells. I'm going to place each zone on its respective cell and then resize them a bit to conform to the grid. And then I'll make sure they're set to detect my grid marker tags. We can see that one's working. Let's make 3 more. Now I'm going to move the rest into place, 1 behind and 2 on either side of the character. We want information from these trigger zones to go to the character. Let's avoid the messy wiring by using some wireless gadgets. I'm going to lay down 4 wireless transmitters in the checker microchip. We've set up some feelers, so let's build some logic that can receive those wireless signals and use them to interrupt player input. I'm going to organize this in a new microchip. I'm going to put down 4 through nodes, 1 for each direction of the D-pad. We can use these to interrupt signals by turning their power off. And then I'll hook the output of those nodes up to the B through D inputs of the selector. Here I'm setting up a check to make sure the signals from the checker are only valid when the character is at rest. However, while making this video I realized this is redundant since player controls are already disabled while the character is moving. So I've removed this NOT gate from the version that I've uploaded to the Dreamiverse. Now I'm going to hook up the inputs of the nodes to the D-pad outputs on the controller sensor. I'm back in the checker microchip and I'm going to name these wireless transmitters so I can set up some corresponding receivers in the character logic. Then back into the character logic in our interrupter microchip, laying down the corresponding wireless transmitters. Right here I'm hooking the NOT gate up to the wireless receivers. Like I said, earlier, this is completely unnecessary. Don't do this. I'm only showing it because I can't remove it from the video completely and I don't want to talk about it after this. A word on the wireless transmission range. In this example, it doesn't matter as long as the signal goes from the checker cube to the character. In an actual game, you'd likely want to confine this to the cell the character is occupying so it doesn't conflict with wireless signals of other characters. To complete this step, we just have to connect output of the wireless receivers to the power of the node connected to the signal they're supposed to interrupt. This way, signal only flows through the node when a tag is detected by the corresponding trigger zone in the checker cube. I'm placing a tag in the character so I can get the checker cube in the same position each frame. Then I'll place a teleporter in the checker cube's microchip. This should be set to match target position and not target orientation. If you recall, for various reasons we want to keep the orientation of the feelers in the camera separate from that of the character. I'm deleting one of the tags real quick to playtest. And we have ourselves a bug. The character should not be able to move into that cell. A couple of minutes of troubleshooting and I noticed that I never set the wireless receivers to specific transmitters. We'll take care of that real quick and try again. And I have another bug. I can't move north here for some reason and I should be able to. Only took about 45 seconds to find this one. Somehow I named two wireless transmitters the same. Top one should be N for north. Let's try it again. I go west. I can move north from there now. Took care of that. Wait, what? There's no tag in that cell. I shouldn't be able to move in there. Another bug. And another fix. Turns out I got my east and west trigger zones reversed. You could actually move them, but it's easier to rewire and reorganize. I'm testing one more time and I notice that my checker cube is lagging behind the character, so I'll adjust this. Probably don't need to, but I want to make sure the feelers don't get out of whack. When you click on the tag in the character, you can see there's a little adjustment bulb to set position, and that is currently a tiny bit behind the character. We want that right underneath in the middle of the current grid tag. That takes care of the grid checker. Now let's set up our isometric camera. We're going to add a camera pointer to the grid checker microchip. Remember, our camera is in the character controller sensor and we want the camera to be independent from the character's orientation. That's why we put the camera pointer in the grid checker's microchip. We'll set the camera to point at the base of the character. We want to set the camera so that it's 45 degrees above and behind the character. That's pi over 4 radians for you math nerds, but in this case it works out to negative 45 degrees tilt and 135 degrees yaw. In a future video we'll set it up so you can rotate the camera view around the character 90 degrees at a time. And here's the end result, which is working fine. I also want to add the ability to deal with different elevations, so I've raised one cell and then built a ramp up to it. We can add grid tags to these cells just like any other. In order for the grid checker to differentiate between levels, we'll need to adjust the size of the trigger zone in the y-axis so that it's just high enough to detect the ramp tag but not the second level tag. When we test it out, it doesn't work because in edit mode we were not considering that the checker cube will be setting its position to the base of the character, so our trigger zone is now too low to detect the ramp. Real easy to fix that. In edit mode, move the checker cube down to the position it would occupy in play mode, then adjust the trigger zones. Another thing I've added is an orientation guide graphic. I'm not going to reproduce it on video because it's tedious. It is a simple collection of 9 text displayers, 1 letter for each cardinal position, a circle for the character position, and the 4 I letters stretching out to the cardinal letters. One thing I'll say about this is that in order to reproduce it, you will need to click the Allow Rotation parameter in the text displayers. Also, in the final version, we would want to set the checker cube to invisible. However, while we're building mechanics, we'll leave it visible for easier troubleshooting. Here's a look at the complete version I've uploaded for Remix. The view is a bit more 2D because I've made field of view as narrow as possible in the character's controller sensor, and then zoomed out with the camera pointer in the checker cube. And that one's in the can. That was kind of a long video. I hope you made it all the way through without falling asleep. I didn't while I was making it. As always, there are more videos to come. If you have any ideas for relatively simple tutorials, leave them in the comments and I'll see you next time.